Okay, yeah, this is Coffee Compiler Club. Anything and everything to do with compilers and language runtimes and typing systems and nillable. And I'm talking to operator overloading somebody this morning who I'm hoping, I gave him a late invite to see if he shows up. Open mic, ask what you want. You're being recorded live. You'll go up on Twitter, generally pretty quick. There's a Google Doc in the second link I sent everybody. So maybe I don't have to throw the link in the chat now. Reserved right to moderate, never had to do it. That's it, let's roll. Here, I can open up. I've got two other people helping me with AA now. Marco Cervetto is in New Zealand. He's a heavy theory guy. He loves poking holes in things. So he's busy trying to poke holes in my theory. He found stuff while I was at conference and I couldn't focus and dive in on it. So that's this afternoon's job. Bobby Eckhart is running a fuzzer and coming up with sort of steady stream of parsery issues that I'm sorting out now. And I'm in the middle of trying to integrate my typing system back on the main AA code base. So my hands are way full, but it's good stuff. Here's Matt now. And that's sort of the long and that's the short and the long. I'm getting more theory notions figured out how to run subtyping with sort of a classical name and interface hierarchy with Hindley-Milner. I think I have that in theory sorted out in my head, nothing implemented yet. Nothing implemented with classical interfaces on Hindley-Milner, but I think I can do it now.
Can I hijack for a bit and ask you another question?
I'm sorry, what?
Can I hijack for a bit and ask another question?
Yeah, absolutely.
Okay. Has anyone here actually been looking at ARM and what it's going to take, as this architecture gets a little bit more popular, and what do they think about the difference between ARM and Intel, and where's this going to lead us?
I gave up on the processor wars years ago. I'm all excited to see ARM win, but I'm standing off to the side.
Well, I don't care about war. What I care about is just what's there, from other people's perspectives.
So from a compiler backend support perspective, or
code generation is pretty straightforward.
Yeah, but that's can you clarify what you meant?
Well, no, I was asking a very broad question just to get a perspective. So if you just have a compiler support backend thing, I guess in terms of the architecture itself, how it differs from Intel, what are the adjustments that we have to make in our thinking because of it, and
so at the Java level, the JVM will plaster over all the obvious differences.
Only if Monica makes that happen.
No, you have to try hard not to. I was part of the ARM port years ago, and I didn't actually do all the low-level bits, but I did a bunch of this setup. There's nothing going on there that's going to be oddball on an x86. Yeah. The memory model had to get sorted out. That was a little weird. And everything else is classic code generation. Yeah. Then you get into issues what's the operating system doing when I ask for high volume locking? Do I have fair locks in the OS or not? But that gets into what Linux is.
Right.
Azul, we had to do fair locks because we have 1,000 processors. You go to an ARM that's a big server box, has lots of cheap ass processors. You might want to ponder fair locks again. I don't know that Linux is going to provide them, but that has nothing to do with ARM architecture.
ARM has about 5 different modes that you compile for. I mean, you have to pick which mode you compile for. So there's 2 or 3 32-bit modes. I think it's 3 32-bit modes and 2 64-bit modes. Intel has something like 17. I mean, pick a number that's more than 10 and less than 1,000.
But there's some really popular modes in both of these cases. So are you talking about just all of the possible modes in general? Because I don't know them. Or are you talking about what goes on when you throw ARM in a server room as a low power server box?
Oh, well, what I meant was ARM has basically 5 execution modes. So
right. There's a thumb mode, a thumb 32, and a thumb 16.
Yeah.
64.
It's been a couple years.
Classic 32, and yeah, right.
I think it's fairly straightforward to pick, like there is like the right one for your use case. Right. So it's really different to Intel, where you can say, okay, like all the SSE in AVX, whatever instruction extensions are kind of their own mode, because you are basically forced to worry about it, because it's like if you start using AVX instructions, you should stop using SSE instructions, because there are very gnarly interactions between them, and it really kills performance. So
right.
I didn't know it killed performance. I knew it was nasty between them, but fine.
Well, that's for a register file, yeah.
ARM is also deprecating 32 bits in the new Cortex-A cores, so that's gone.
Okay.
Yeah. And in general, generating code on ARM is nice. And the one time I did it on x86, it was like worst day of my life. It's like it's really, really, really bad. It's like there's
the worst day of your life?
There are a lot of things where people say, okay, this is really, really bad. But
there's a simple trick to x86 code generation. These days, and for the last 15, 20 years, you treat it like a 16 register 2 address RISC, and you put an assembler underneath you that just does all the fucking weird ass translation crap in the world, and you ignore all the strange encoding things.
Yeah. Then you run into exactly these things where you like have to worry about. So if you have if you pick instructions and you do SSE, then like using SSE is fine, and sometimes even shorter. But as soon as you start using one AVX instruction somewhere, you have to worry and have a look. Okay, do we swap out all the SSE instructions with the equivalent instructions, but for AVX? And it's like,
you know, when I started down on hotspot on x86, we did all the hard way, and then some years later when I revisited it, I wrapped this layer around, and the FP instructions looked like a standard FP register set, and it was really SSE backed, and I could just flip a switch whether I was going to go try the stacked shit or do the SSE.
Yeah,
I would have the same switches. It's all going to be AVX, it's all going to be SSE, and nary the twain shall meet. And
but I think at this time, I think you will never ever use x87 stuff.
Oh yeah, no,
ever.
I think so. Yeah, right. Yeah.
And that's a bit annoying, because a lot of the intuitive things you want to do are like some weird complex vector packed instructions. But yeah,
I think the only thing left on there are like they had so much of a log and tangent sine cosine shortcut instructions there, and I don't know if they all made it over to SSE land. I remember we had to support them. We had to support inlining all of the inner loops of the intrinsics for sine and cosine onto the, I want to say 87 transcendental ops, but then wrap them with safety wrappers so that it would function correctly and give you all the right precision bits. So there was some set of conditions where you loved or hated for transcendental, where you gave it up and you did them like soft lib and you just like grunted it out in software, versus using the transcendental ops. And I remember doing all the work to have a flag to turn it on and off, and doing all the work to fucking use them when it was appropriate and not otherwise. And I have no clue if that shit's still turned on. That would be like weird, but maybe. Yeah, but the other ops, no. And to get back to Kirk's question about ARM, I think from a code generation point of view, it's pretty straightforward. I think from an OS support issue, it's pretty damn well supported.
I think the code generation aspect, especially with ARM v9, the interesting part is SVE, or scalable vector extensions, because that's rather different from the other existing ISAs other than RISC V. So you basically have vectors, vector registers, which can be of different length, and the ISA does not commit to one architectural length. You can have multiples of 128 bits going up to 1024, I think. So that's different from the x86 side.
Yeah.
But I'm looking for the link.
I mean, I found x86 vectorization to be awkward, to say the least.
Everyone's just using LLVM anyway, right? Except for
I'd say Hotspot does short form vectorization on SSE ops. I assume they've done it for AVX.
Yeah, we did some other stuff where we actually went in Hotspot and changed some of the vectorization for a couple of workloads, and I don't know. I hadn't done any vectorization on.
You manually did vectorization.
Yes.
Yeah, you should try vectorization on a couple of different things before you claim that x86 is worse or better than anyone else's.
Well, I mean, I really hadn't actually done any real vectorization work since I was working on Craze, and vectorization on those systems was brain dead simple.
Yeah, right. Yeah, but I have stared at a bunch of them since then, and it's all like short form. You have to do unroll and jam or scale replacement or any number of other things, and they expect the compiler to really pile in on it.
Yeah.
Doing it manually is sort of like, yeah, a pain in the butt. Core inner loops of video codecs or something maybe, but otherwise I'd get a vectorizing compiler and walk away.
That was our third vector register when we decommissioned our XMP.
Excellent. Excellent. I actually have an old Azul motherboard up here on the, let's see, you guys can't hardly see this in the far, with my finger point straight at it, right? My finger's on it. That's a 4-chip, each chip having 48 cores, Azul version 2 with, you know, I don't know how many gigabytes of RAM and everything else, whatever.
Yeah. Ancient history.
Ancient history now. Yeah, sucked, but it was most fun chip ever to work on for me was that Azul box, but wrong business model.
Yeah.
Cool hardware, wrong business model.
So did anyone have a look at the vector instructions from RISC V?
No.
So the vector extension is pretty similar to ARM SVE. They also support different multiples of the vector lengths. It's actually a little bit more complicated because you can also change this at runtime. You do not actually change this with SVE as much. There is a privileged instruction to change the instruction, and for ARM, you can do this via process control on Linux, but it's actually a little bit more flexible, which poses some challenges on the code generation side, like adjusting the stack size or passing the structs which contain data members which are of those vector types.
Okay, I only had a short look at it, and I had the impression it was designed so that you could generate code and it would work regardless of how many large registers CPU had, in fact. So
yeah, so that's true both for RISC V and SVE. It's the so-called VLA, or vector length agnostic code generation, where you basically generate the code assuming that the register size is unknown. But you can also generate vector length specific code. And there are some trade-offs, pluses and minuses, because if you are using vector instructions and you are tuning for specific microarchitecture, things like cache line size, the knowledge that the given CPU happens to have a vector size, say 256 bits, is something you can exploit for performance. And oftentimes you actually use vector registers when you use vector instructions, and you use vector instruction because you want performance. So I think it's an interesting layers of different applications that may pursue different strategies. Yes, you get the benefits of no recompilation of binary code when you use the agnostic code generation, but you also get benefits of even more fine-grained microarchitectural tuning. Think of like writing the linear algebra package or machine learning libraries when you actually tune with the knowledge of specific vector size for a specific CPU core.
This is why you do runtime code generation.
That too, yeah. Yeah, I think JITs actually may have some interesting exploration to do here, because you will have very interesting choices.
Yeah. You could also ask questions about the size of the arrays involved, things like that. You're doing your code generation. All right, are we done beating ARM to death?
Yeah.
Yeah, maybe. All right, so I have a different question here. I'm wrestling with operator overloading syntax, and I'm trying to figure out what's the right way to express. I'm gonna go find the Google Docs here. So for all the newcomers, in theory, there's Google Docs in your link. The second link that went out had Google Docs in it. So what I did here is I said, if I throw an underscore in the name, and I'm missing some other bit that says it's an operator, but as soon as it has underscores, it's an operator, and the operator means, the underscores mean this is where the arguments go. So here's an operator overloading for plus. Here's a unary negate. As a prefix, here's a postfix.
Agda does them this way.
Yeah, so I can say which way the argument goes. And then, you know, here's a version of a collections lookup called array and index. And here's a collection assignment. Array, index, val. And you know, what do you think about this kind of a syntax?
So I think my approach to this is to not have number 2 and 3 at all, and the rest are methods.
Well, these are all methods under the hood.
Yeah, so, but also use normal method syntax. So there's like,
you're just using normal method syntax.
There's like some syntax sugar rule, for instance, like if the method is called plus or something, or if the method is called get, or if the method is called set, then you
Python, if I do, you know, name methods a certain way, in like under get, under index, I forget what the syntax is. Then they give you the operator version of that. So the underscores go away in the operator usage, right? This is me giving you a name, but the use for plus is exactly like you think it is. It's just like that. And the use for the array lookup is just what you think it is. You know, it's.
Are the spaces significant in your notation?
Not when the operator is being used as an operator. It is when it's being assigned as a function. If you're defining an operator, you have to have no spaces in there. If you're using the operator, you can have spaces. The underscore replaces an arbitrary expression plus white space. So in particular, in the array assignment, you know.
So you're saying like the name of the operator is that 4 or 5 character.
Right. That's the name of the operator. When you use an operator, you can put spaces anywhere. And including in the trinary operator version for the collection assignment, you have 2 pieces for the name, and parts go around. And I'm not claiming this is the best answer or the worst answer.
I would be careful, because like it's really hard to remember especially the array variants. I think it's really hard to remember. And B, Scala tried some of this stuff with its getters and setters, and it really sucked.
Okay,
it's so like if you wanted to implement a setter in Scala, you had like underscore something, and it wasn't.
Okay, so
it was bad, and encoding they encoded the method on the JVM using a white space thingy, and that was even worse. So
okay, so
I can't recommend it.
Here. The array notation I'm using is identical to the array notation you get in every array notation language on the planet. If you're not doing an operator overloading, you're just using it as an array, it is the array notation. There are no funny games here.
Yeah, I wouldn't use
assignment overload the operator. When I use the array notation for an operator, such as a dictionary lookup with a string key, right?
I wouldn't use array notation to begin with.
Python does. With
but what's the point of having overridable array notation if you like if it's not restricted to arrays. I think from my point of view, it's a dead weight. It's like language, it's like a complexity cost in a language design that isn't getting repaid. It's like, why it's basically you're wasting a perfectly good set of brackets for something which could just be that,
well, they're being used for arrays.
Yeah, but use round ones. Who cares? It's like
use round ones like an apply method.
Well, I can't do an assignment into a dictionary with round brackets only. I now have to have extra arguments with extra commas to do the dictionary assignment, which maybe is fine. I'm not saying no or yes. I'm just saying, like, I want to do dictionary assignment.
Cliff, I'm surprised that you would like this sort of overloading, because I thought when you're reading code, you like to know that you're like looking at a direct field access.
Right.
And I always hate this stuff because I think I'm reading one thing and then it turns out,
it's something else.
Something completely else.
Yeah, right. And this is one of the reasons I'm happy to ask opinion here, is I go back and forth on this game. I've used operator overloading for collections strictly, and for variable length arrays, or growable arrays, as an overloaded array operator, and where I found it to be reasonably convenient. So there's a very limited set of things I thought it was a natural fit for. So variable length array was not a normal length array. I don't want to have variable length arrays baked into the language where all arrays must have an extra set of features and costs associated with them. So all arrays are C-like, Java-like arrays. But sometimes you want to have a variable length array. You're willing to pay the cost, that's fine. And then you use array syntax on it.
So my 2 cents is, like, in reading, I like to know when I've reached the bottom. So I hate the operator overloading because you're never quite sure.
Right.
And I know that the IDE can tell you, but
Right.
I like knowing when I'm no longer playing with somebody else's stuff.
Okay. No, that's good to know. That's a.
So another comment I have here is that it's not clear whether you're dealing with L values or R values all the time.
Yeah.
So your postfix increment.
Postfix is weird.
L value, and that's a completely different ball of wax to all the.
Right, and in fact, I don't have the postfix one implemented because it's an L value, and I haven't figured out how to do that well. So we could subtract the postfix incrementer and claim it's not I can't do it because it's an L value. And that's a perfectly fine thing to say.
But you're going to need, or you're probably going to want L values at some point, because say you want to define the plus equals operator independent of the array access operator.
The array syntax fixes the L value because you break it up into an array and an index. The combination of those two is your L value.
Yeah, I understand, but I think it's going to lead to ambiguities, because you can, bring a set of operator definitions, and now it's unclear whether you meant to use these two operators or this one operator.
Okay, the operator syntax itself will be sort of, I think, pretty obviously non-ambiguous. It's a question of whether or not you like knowing you hit bottom or not.
Well, yeah, it's like Mark's comment, right? Is the bottom, do we reach the bottom where we're going to use, an array access operator and a plus equals operator, or is there a single operator called array plus equals?
Oh, there would be a single
operator. You can't tell
operator
by looking at the use of it.
There would be a single operator array plus equals. To do the operator overlaying with a plus equals, it would be a single operator array plus equals. Plus equals itself, I don't have implemented because it's an L value.
Based on the examples you've given, you could do it either way. And so a reader of the code doesn't know whether one or two or three operators are involved, right?
Right now, the operators are entirely unambiguous, but there's another piece that maybe you haven't seen yet, and that's white space is not allowed between the tokens of an operator, except for the three-piece operators, which have somebody in the middle. Everywhere else, if I say...
so I'm not talking about the definition of an operator. I'm talking about the use of it.
Yes, in the use.
If you don't have in your head all of the operators that might be applicable,
right,
it's not clear what you're saying.
I see I hear what you're trying to say, and I claim that I have syntax restrictions in place that will make it unambiguous in a very short span of code.
Is that there are two different ways that you could compile the same expression when you're talking about an array plus add, plus equals, for example. Is that correct, Keith?
Yeah, I'm putting a plus equals in the thing now.
You don't even have to go that far. The fourth and fifth operators define the array access.
Yeah.
And the array access equals are both available for the last line on the slide, right? Where it's
no. As soon as I have the rule in the operators is that the bracket and the equal, if they're part of the operator, they have no space. They're not allowed to have a space there. No.
I'm not talking about I understand all the definitions.
No, in the use, you're not allowed to have a space.
Okay, so now space is significant in the
use, yes. You can have spaces where I've placed them in and around people are hacking it furiously here, in and around the tokens, but a token is a closed bracket equal. Those two characters side by side, no space. So there's two lexemes or two tokens here. There's an open bracket, there's a close equals.
Okay.
Now, so you can argue that you don't like that also, which is fine.
I'm going to tell you I don't like that. That's I guess,
okay.
Back to Mark's comment about it's not clear what I'm saying. Because if I put the space between the closed square and the equals, it means use the fourth operator. If I don't have it, it means the fifth one.
Right. If you put the space there, you'll make the array lookup operator, which doesn't do assignment. It's a value. It's not an Lvalue, it's a value. And you'll get a syntax error.
Okay. You wanted to use an Lvalue in the line above with the post increment.
I'm claiming the post increment is not implemented, and I'm going to put a comment here that says,
okay, but
not figured out yet.
Yeah. Okay. So if you're ruling out Lvalues.
Yes. At the moment, I'm ruling out Lvalues because I don't know how to do them in any kind of reasonable syntax here. Yes.
Right. Now I got a different problem in that I need to have an assignment or an array assignment, operator independent of the plus equals, minus equals. Like I got to have all of them because I can't just say, array access and use a different plus equals operator than the one that only applies to arrays.
The plus equals without an Lvalue. So if I have no Lvalues, you're stuck with a separate operator for doing plus equals on arrays versus regular assignment.
Yeah. And
now,
so every
syntactically, they'll look the same as you would expect, but semantically, they'll be unrelated.
Very different. Yeah.
Yeah. To fix that, I have to have Lvalues in the language. And if you look at how these languages work, the Lvalue situation's weird. It requires a semantic change, and I haven't decided what I'm doing about Lvalues. I'm not sort of interested in supporting arbitrary unmanaged pointers. So pointers are managed. As soon as I have managed pointers, I don't have Lvalues per se. So an array with an index is an Lvalue where the base of the array is managed and the index tells you the offset, which is fine. If I say I've taken an arbitrary address of a member of a struct, I have an interior pointer as an Lvalue, and that becomes difficult to deal with from a garbage collection point of view and difficult to deal with from a typing point of view, and I haven't decided what the hell I'm doing with that. The current theory is to say no, or I'll go to some sort of unmanaged mode where we all admit that this is in your trusted computing base and you can shoot yourself in the foot, but the typing system doesn't get to help you. And I don't like that one either. So it's an open question right now. So I have no Lvalues at the moment, per se.
So I think that options were agreed.
I think the core question is whether you really, if you think that this operator overloading stuff is a good place to spend language complexity budget on it, because
a fair question.
Yeah, it's like I think I put I put an example. It's I think the second to last one, and I'd say it's not the most beautiful one. it's not the best one, it's not the most convenient one, but it's absolutely the cheapest solution you can have, where you say, okay, I have like these two syntax sugar rules, how I write index our array access and array write, and I'll spend language complexity budget elsewhere. So I'm using this approach and I can recommend it. It's like, it's not something that keeps me up at night to say, okay, I need a more fancy array access syntax or something. It's
mainly valuable though if you're using the square brackets for something else. Sorry? If you go C style and reserve the square brackets for array access, then
yeah, I wouldn't do that.
Two decisions kind of go together.
Yeah, so
do that.
One of the complexity, one of the language weirdness budgets going on here is that I want to use square brackets for arrays. If I drop the operator overloading, I'm still going to have square brackets for arrays.
But I would add that these kind of overloads push the language into a low-level machinery, for loops, iterators, etc., etc.
So I don't see both Simon's and my syntax, as far as I can tell, are unrelated to for loops.
The array access, you reserve the brackets for array access.
Yes.
This can be spent elsewhere, as we mentioned it earlier. And at least my personal opinion, that operators like this push to a low-level machinery, to a for loops, to an index of arrays, and etc., instead of something like a map, flat map for high, something like this.
It's a bit of my reasoning too. It's like I don't need to have like special array syntax or like fancy for loops or anything like that, because I don't plan.
For loops are unrelated here.
Yeah, but I just from the school of thought, it's like I neither like are interested in fancy array syntax or for loops or something like that, because it's like I am not planning on. I don't want to write code like that, and I don't want other people to write code like that.
The fact being there as if some
a huge count of code on the planet is written like that, and
there's nothing wrong with it. There's nothing wrong with it. I'm just making a point.
You don't support people who write for loops over arrays. You cut out like 99% of the shit that makes your life actually work. Like the internal guts of every OS and every device driver and every piece of your phone and everywhere in between. So this is like the people that make shit work, not the fun language theoretical pieces, but the shit that works. And that's why I definitely want to support that crowd.
Nothing prevents them to compile to the same thing.
Can we talk about Ruby on Rails and how to slow Twitter down? I want maximum 5 tweets per second.
I'm exactly.
I'm killing you, man. Sorry.
Yeah.
I would say that nothing prevents them to compile them into the same way, but using
the way
angle brackets.
Okay, the way that Simon wrote it with round brackets can clearly be boiled down to the same code as the square brackets. That's not the issue. The question becomes, if I'm writing array-like code, how much support do I give somebody who's doing array-like work? Where array-like means I'm walking through network packets, trying to decipher your network structures. I'm trying to do a JSON to non-JSON DOM conversion. There's 1,000 uses where I have arrays that I'm walking through big piles of data and doing shit. Okay, suddenly you have questions like, what's the performance of this code? And that goes to Mark's question of, when did I hit bottom? Right? This isn't yet another function call. This is actually an array cost. And there's a cost model, and I have rules on cost models that are kind of half-baked and kind of there on what it makes sense to be, what's the cost here and not the cost.
I'm tempted to say that RISC supports the latter way, the map and the flat map, and the iteration is structured like a more functional iteration. I may be wrong, though.
I would look at modern domain-specific programming language for array. It's called Fortran. So in modern programming languages like Fortran, you can, for instance, say A equals B when you want to assign array B to array A. And in terms of cost models, that you're getting optimized and vectorized code.
But you're
so now you have no aliasing. That's, I think, what you just tried.
Wait. the cost model has to include just a whole array copy, not a reference pointer copy.
Of course, and note also you have no aliasing in Fortran, and this is also something to start with. So no reference semantics with shared mutable state as in managed languages today, because that ruins most of those performance optimizations.
So, okay.
But you can also use dissection syntax. Like if, for example, if you have an array, two-dimensional array, you want to do something to every row, but you want to do something for every column. And this comes up all the time. I think it's a good idea to design multi-dimensional array syntax at the same time you are designing any array syntax.
So my theory on that one is those all become operator overloads for people who are excited about doing array slicing. Yes, Chris, we know who's loud. I have the mute button in hand, by the way.
Oh, thank you.
No, Matt,
what
you're
if
great.
you try and have two syntaxes, where you have one syntax that is like thing at index that is allowed to be overloaded, and one that is brackets that you don't overload. And if I don't actually care whether it's the cheap one or the expensive one, I use the at syntax to access things. And if I know I need just math, I use brackets.
So, okay, so I'm looking at somebody else's operator overloading definition where they say at op and the string. Although if you do the square bracket equals on that string, it doesn't say how you split to put the index between the square brackets. So that's what my underscores was about, was just where the three parts go. Agda infix 30, yes. And my add function for integers is int to int to int, yes.
The underscore sets how to associate the operator from to the left or to the left, or infix.
Yes, the underscore just counts arguments left to right. And so you can choose infix, prefix, postfix. And for three args or more, it just lays out where they land. No reason you couldn't have more, although I don't have it currently set up in the parser that way. All right. So the one constraint that I heard that I agree with and haven't sorted my head on is, when did you hit rock bottom? And the usual rule in C is square brackets are rock bottom, and the same for Java, square brackets are rock bottom. In Python, square brackets are not rock bottom. And but Python doesn't do performance. They switch to C when they're going to do performance.
And I'm surprised Mark's complaining about that, because he uses ecstasy, which has no bottom.
I believe I have complained about this in ecstasy.
So where is your cost model? And I don't know what to do with this one. It's not a function call. It is a function call, and except it's not. So for the array guys and for certain of the primitive, for all the primitives, the guaranteed rule is they all 100% inline every time. So the cost model is whatever you expect out of the C version of the same thing. As soon as you have an arbitrary overload and it's a random function call, obviously it's not going to inline every time. So that I don't have a good cost model rule there. And then you can't tell.
Right, but you could have a convention on your collections that says,
yeah,
I'm always going to overload at to be array access.
So that's,
and now if you say thing at index, you are going to get either the array index or whatever that object feels like doing.
Yeah, I'm
and if you use square brackets, you get the cheap one.
But putting semantics into interfaces has been a fool's errand for at least 50 years now. I mean, I don't disagree with the goal. I've never seen it done in any way that didn't completely suck ass.
Which one? Sorry.
Putting semantics into API constraints, like.
Oh, I see. Yes. So I can put the @ sign. Is that Aaron saying that one there?
Because Aaron, that reminds me quite a bit of some of the ideas in Eiffel. Not to date myself or anything, but yeah, I think Eiffel tried to do quite a bit of that with the contracts,
preconditions, post conditions, and so on. Yeah, I played with Eiffel too.
But I mean, they were basically trying to build semantics into the API itself, and it
didn't work out well.
Well, it worked out great for simple examples, and then it kind of fell. The return on investment went from 0.5 to 0.00000001 in a hurry.
My experience with operator overloading is in some very narrow situations, it has a payoff. and you can easily run yourself into a hole in the ground, and it's not worth it.
Well, I hate to think of it as operator overloading, though. It's not operator overloading, it's operator definition, right? So you have to think of it, instead of saying, oh, I happen to hard code this thing for array, and I'll let you hack it into your own library as well. That's the wrong way to look at it. You have to look at it as, my compiler defines this operation. I happen to define it on array. You know, if you define a type that it makes sense on, you know, but it's not operator overloading, because that implies I have magic hard coding, and then I put some hack in so you can.
I'm doing it what you were saying was a good way. The parser parses it as just a lookup. I happen to have a predefined primitive lookup that hits on that syntax. That primitive does a thing that is not legal for anyone else. It goes to a backing implementation of an array assignment syntax or array lookup syntax, because I have to bottom out somewhere, and I bottom out there. But the actual operator lookup, that's generic for anything. And in particular, I have these defined in a prims.aa that's read, you know, underscore prims.aa syntax file that's read when I start up right now. I mean, this is me in the last 2 weeks. And so they're all like, the primitives are now in a AA file that you just parse in.
Sorry for my 600 millisecond ping time. What I'm looking at for the operators, I don't see specialization of these operators, so that you may have two types of things in your, you know, pseudo language that have index operators and doing completely, you know, unrelated things with indexes.
Right. That's the typing game. So having defined an operator, you give it types. I didn't give any types to those operators, but I have to, and I do. And the disambiguation's done by the typing system to say, this is the left-hand side, it is an array. So of all the possible square bracket operators, I find the one that is the array left-hand side. The right-hand side is an index, it must match an int, and you know, and then that's the resolution. So if the left-hand side is a person and the right-hand side is your children or child, first child, second child, whatever, you look up on the left-hand side, you find the operator, you disambiguate and you go. Does that answer you, Jim?
For the most part. So what you're saying is that in the examples, index would have a colon with a type int in order to specialize for some certain array.
I'll put a colon array on array. That's my left-hand side. Now the right-hand side, I can do type inferencing, but probably index is an int. To get the primitive version, it's actually an int, and in fact it is, so you're correct. So I'll do int there. So I'll throw the type annotation in, and that's so that I have a narrowly defined operator, and you'll get, if you match on the left-hand side for an array and your right-hand side is a string, you'll get a type error. They'll say string is not an int, you're dead. And if the left-hand side is a person and you have an operator overloaded for a person and you take a name for an index, then you do, and that's fine.
Okay, so I can't consider this at the top level without tracing back through my experience using delegates as in C# or Kotlin, which specialize inside the type itself. You know, let me think about that.
Okay. But there's no, in this case, as far as I know, there's no type specialization. Inferencing happens by the type system. So I don't have to add those annotations typically. But in this case, I threw them in the doc, so it's obvious. In some of the primitives, I do need the annotations because I need to force it. Like my primitive, the primitive, there's too many layers of primitives. The primitive that is written as AA syntax, that is the function call, the compiler just parses through handles. There is a primitive that I bottom out as with a magical special $, you can't use this syntax, that bottoms out. That guy has types, and he can force inferencing on the wrapper that you see at the primitive level, except that becomes error prone as I change things. So I just throw them in, the actual types, in the AA file I'm using for my prims, but I could, in theory, infer them. I don't have the inference perfect for all the overloads either. So at the moment, I actually do need them, although the intent is to not need them.
So, you notice I added my comparisons with Smalltalk for your operator definitions.
Yeah. Go scroll down and find it.
Viewed in that light, we're really only talking about syntactic sugar.
Oh, a Smalltalk output add. Yeah. Yes, these operators are syntactic sugar for a function call. I got a helicopter off my window. Just a second here.
So
for map, sorry, Jim, go ahead.
Okay, so I keep coming back to the ZR1 analogy that there's two keys that you get when you buy a ZR1. One is the normal key, and the other is the valet key that doesn't let you get out of second gear, I believe it is. So, when you give the valet your key to your ZR1, they can get in and out of a parking lot well enough. They can go up to 50 miles an hour in second gear, actually probably 80. But
get to the point.
When you have the key to go into all 7 gears, it's a different car. So, you're going to get the fundamental language complexity argument that would gladly take down the opportunity to perhaps operator overload, the entire JSON syntax into compiled language, which would be a win if you didn't have to write a parser because you had operator overloading to affect the brackets and braces that
I'm not
do
certain
JSON.
I can do JSON directly, but it would be interesting concept to think about if I could, but it's not a goal. How about that? It's not a goal that I could parse JSON as straight up language syntax. Bye.
Yeah.
If it happens to be true, but the language and also the language is usable by people in this audience right here, then I'll accept that. But I'm not going to twist the language to allow JSON and at the same time, like shoot Marco in the foot by making Falco in the foot by making it impossible to tell where you bottom out.
Well, this exists in JavaScript with the strict keyword. Perhaps the valet key is the default syntax. And when someone wants to extend grammars, extend functionality through syntax, maybe there's a scoping hint that says, here be dragons, let's go.
There's always scoping on these operator definitions. So if you define them for you, you define them for you, but they never escape your scope.
Well, some languages do, so be careful about that.
Okay, so very clearly,
I think there's also two different
syntactic sugars for a function call, and as such, their definitions land like every other syntax assignment and function assignment, and they are scoped. So they will not escape the scope.
There are two different audiences, though. Like there's the you and Mark audience, and that's not.
Yeah, I know. It's not the wide audience. So always with operator overloading, you never have to buy into it. You have to go write an operator if you want operator overloading. And then there's people who misuse it and make their lives miserable.
Well, it's not about me. It's about the other guy.
Exactly.
Exactly. That would be my point. I mean, there's languages that give you a couple of operators you can implement, overload, whatever you want to call it. And there's those languages that give you the option to define arbitrary lot of operators, and people do that. And I never understood why.
Right. Well, if you lived in their shoes, maybe you would, and maybe they still shoot themselves in the foot because they're exploring. I've certainly
always come back to
who want to do array math, and they love to have operator overloading on the array math.
All the operator overloading gives us, like for this whole discussion, it just makes the code a little bit prettier. Like I never understood, like, put on map always looked fine to me. I don't need square brackets to do my put. Like, so why have it?
Because
do we really need overloading?
It removes one more piece of complexity from your mental model, lifts up a layer. from I'm doing a put operator on a map to I have a mathematical collection, I'm growing it, and I'm shrinking it, and I'm manipulating my mathematical collection. And I get to move away from the actual low-level implementation piece, and also while I'm trying to think about my high-level problem I'm trying to solve. I understand why people want operator overloading. Those who want it, I think mostly have a reasonable reason to want it.
Yeah, I suppose the other way I could be satisfied is by, you know, like, let's use the square bracket for overloading, but then give me some other way to know that I'm looking at, you know, the bottom, right?
Right.
Like direct array access could be something uglier.
So we had an alternative syntaxes thrown up there, including at, put for small talk, and the at sign, which I threw up. I could just do the at sign directly right now as a, you know, this is, or whatever it is. But in all these cases, for me at least, as soon as the parser's there and understanding how to parse these things, it's understanding an operator overloading. If you don't overload it, you get the rock bottom performance. If you have to edit somebody else's code where they're doing operator overloading, if you never use operator overloading, you're not touched here. If somebody else is hacking operator overloading and you have to go modify their code, now there's a problem because you have to understand what they were doing for operator overloading. And that's—
all right. So a really good example of where operator overloading restriction has a downside is the data engineering tool Pandas in Python. You know, the overheads of the CSVs that you're loading are like 10x because of all the bouncing between NumPy and Python workarounds, and
Python
still getting
is not
Python
the
index.
way to go read CSV files.
Well, okay, but you got to argue with the entire data science community to make that point and win it.
I've run a startup and I sold my half and did pretty well for doing big data machine learning. And the number one first step you do, eat fucking giant CSV files that are badly formatted across terabytes and terabytes in size. But no question about it. It's a no-brainer.
You being technically right doesn't change the fact that there are 100,000 people using Python for every one person using H2O.
Okay, yeah, no, that's fair enough. That's fair enough. Once we got the CSV in, though, we could throw it at Python directly, but
yeah,
you had to get it in, and that was.
So the question is how to trick the 100,000 X.
Oh, you write the Python, the CSV interpreter.
Right,
you write the CSV interpreter in C. Once you've got it sucked in as a data frame, you hand it to Pandas as a data frame and life goes on. And I think that's what most of them do. They call read CSV, which I believe bottoms out in the C function.
I have a question. What are you really trying to do here with these square bracket stuff?
Well, for arrays, I want to have a classical, so there's a couple of things I want to do with these square brackets. For arrays, I want to leverage C and Java programmers' understanding of what an array operation is. So they will naturally see that and say, we're doing array things, which would be correct. And you would get the array performance that you would expect out. So that's the number one thing. The second piece, and it's a lower tier, is to say, I have personally enjoyed using array syntax both for dictionary lookup and assignment and for variable sized arrays, which were growable on demand according to the use. Same as an array list in Java, right? STL has these in C. So those are the main criteria. So as soon as I open the door to say I can have more than one meaning for an operator, that I can user-defined operator, sorry, I can have a user-defined operator, then becomes the giant higgledy-piggledy pile of what the hell people do with it. Sometimes they do crazy shit and hurt themselves. Sometimes they hurt other people who have to go maintain their code, don't know what the hell all the nested operators are doing.
Yeah, I think there's two solutions to this, really. You either get rid of operators or don't allow overloading.
Yeah, don't allow overloading is one of them, yeah.
Yeah, quite honestly, because, I mean, you're right. I mean, the square bracket to me makes sense on things that are arrays or look like arrays.
Well, that's the trick. If it's an array, you get what everyone does in C and Java. If it looks like an array, but it's not technically implemented as an array, you can still imagine using array syntax on it.
Okay, so now we're talking about abuse, and you're trying to prevent abuse. Right?
Yeah, well, I'm happy to give you enough rope to hang yourself, but I have to decide if I'm going to scare off Mark because I've handed rope off to somebody who's going to, hang himself.
Right. So basically, you're trying to make it so that people can't do dumb things.
I would like to prevent that, and I don't know how to, and also allow people to do fun, smart things with operator overloads.
Yeah.
So there's a suggestion given to me. We didn't implement it, but I like the suggestion. So this idea of kind of an advanced user flag.
Yes.
So code that only compiles if you basically sign a contract, right? Say, I actually know what I'm doing. Right?
No, you can't get, I know what I'm doing, but you can get, I take personal responsibility for fucking this code up.
Right, but the point is that unless you, or even do it on a feature by feature basis, to specifically say the compiler will now allow,
so this would be
done.
pound include, I'm going to like hurt me now with operators up front, and then now I can operate overload.
I think command line compiler.
More seriously here, right? If you look at the idea with Smalltalk, right? We just didn't have operators.
Yeah.
So really, what you're doing is method overloading.
Yes.
Right?
Oh, the actual implementation is all method overloading under the hood. The operators are only syntactic sugar.
Yeah. Okay. So the question here is then, you're not going to be actually able to protect anyone from doing silly things. So all of these syntaxes to me are like a bit fugly and somewhat confusing. It's like, if you want a square bracket thing that you can overload, then why do we have all these other things? Just have the square bracket.
So I have okay. So there was another suggestion, which was no other operators other than square brackets. And you can imagine plus equals and minus and divide equals and shit like that, especially for like arrays.
Right.
It was Matt's point is Fortran arrays. Limit the count of the things you can do with operators. So @sign's not an operator. And %, $, up arrow, ampersand is not an operator. Shit like that, right? So there's a thing that says I only allow the following 5 or 10 syntaxes for operators and no more.
Yeah, so let's confuse the crap out of everyone even more, right? So like, hey, I can overload this, but I can't overload that.
Well, I've been in those languages. In R, you can pretty much overload everything you want to be an operator, and I don't claim it helps. And there are very few people who abuse it. There are definitely some people who come up with some funny syntaxes, but they use them in an operator-like way. And once you understand what they're doing, it works.
Yeah, but did you hear all the gyrations you had to go through to get to it works?
Yeah, I did.
Okay.
No, I've lived this.
It translates to that's not readable. And really, I think your responsibility is really not to protect us from our stupid selves. It's to make sure that whatever we do is readable.
Well, that's the Go formula. That's the Go.
The goal is not to protect, it's to make it readable.
Yeah, that's the rule for Go, which I claim makes it painful to use unnecessarily. They went too far. Maybe you could argue Go went too far on it must look like this, but hey, we don't have any interfaces, and hey, we don't have any virtual calls, and hey, we don't have any this and that and the other thing, or generics or whatever the hell, because it makes code unreadable.
Okay, so I'm curious to know how that makes code unreadable, but anyways, that's another
question. That was, primary goal with that and the formatting. Hey, you have your own formatting you've used for 40 years, but you suck. So use our formatting because we know best.
Okay. So what I'm trying to do is I'm trying to tease apart the concerns and try to figure out, okay, what do you want to emphasize, right?
Yeah, fine. This is good.
Do you want to, so do you want to emphasize, readability, or do you want to emphasize protection?
See, readability is in the eye of the beholder.
I think you can get both. Readability is in the eye of the beholder.
It is.
Oh,
well, a low entropy language will be harder to write terse code in.
And okay, yeah. So the physicist who's busy trying to implement high-level equations in a low-level system gets into wanting operators because he's going to do a lot of things that his mind have up-leveled. And if you're not the physicist, it's like, what the fuck are you doing here?
Yeah. Okay. So you want APL?
Maybe, yeah. The back and forth, there's a thing there, and that's what I'm talking about in terms of there's a flexibility. You're going to give out the language.
Right.
You're not in that domain.
So what you're actually talking about here is trying to encourage people to basically develop a vocabulary that they use in their domain, and to use that vocabulary in their code.
I think it's too strong of a statement. I'm trying to allow somebody to choose that he wants to write a DSL, a specific language format for his domain, and use it amongst his peers.
Yes, and I think that's what I was saying.
Okay, but I'm not saying you can't write a DSL, which Go, for instance, totally says you can't write a DSL. Java makes it pretty fucking hard to write a DSL. Yeah, macros in C, you can totally fuck yourself up with a DSL and macros. I have been there too. So,
okay, so again,
DSLs, right?
The codes, because now it seems like we have three different concerns that we are trying to mix here. And I'm just wondering, you know, what are the tensions between the three different concerns, and are they actually all three of them achievable in this case?
I don't know that they're achievable. It's just a question of what balance do I end up getting, like all three. I'm going to claim if you don't do operators, I have a very simple syntax, and I'm hoping that it's readable, knock on plastic. If you do operators, you have to be prepared for, you know, hurting yourself. If you do operator overlay, be prepared for hurting yourself and hurting the next reader. But that's a personal responsibility I lay on the programmer who's decided to use operators in the first place.
Okay. So where I'm confused is I don't know where your emphasis is, because you seem to have not untangled all of these different concerns in your thinking.
That's probably true. As I said, I've used operator overloading and I have used DSLs in the past, and they have been useful. There's a reason for a DSL.
Absolutely. I completely agree. I've used DSLs in the past, or made them, created them, because
so I want to enable that.
Because I can succinctly describe what I want, a solution to the problem, right? Very succinctly.
Right.
And would someone outside of the domain understand it? Probably not. But people in the domain should look at it and immediately know what's going on. And that's the whole point of a DSL.
That's where I'm trying to enable.
Right. And then, okay. So again, is that your emphasis? Right, because that sort of ties into readability.
I have many emphases in this section. In the case of the parsing operator overloading syntax, it's not a huge implementation effort.
Right. So maybe
I'm hoping with minimal effort to enable a certain crowd of people, the DSL writers.
So maybe what you need to do is go for like a walk around the extended block and see if we can like detangle some of these things so that you can, you know, try to separate what you're doing here. Because I mean, your discussion is as interesting as it has left me entirely confused as to what you're trying to achieve.
I'm trying to achieve a lot of things.
Coming through in your speech, I should say, in this flow of thinking, right? Which is really interesting, but, you know.
You're on mute, Tidor.
I think the question to ask is whether there is a local optimum between APL on the one side and Java on the other side, because I think you can build some kind of method overloading or operator overloading or whatever, but the question is, will you end up with something that makes both Java developers happy and APL programmers happy, or will you create a situation where it's where it's like too complicated for people who want to keep it simple, or not powerful enough for scientists who just want to use the syntax there?
For the operator overloading section, I claim the easy answer is by fiat you say no, and then you don't deal with operator overloads. You don't look at them in any of your code. No one can force them upon you. And then there's not an issue.
Because I think that's like if I say, okay, there is a local optimum somewhere between Java and APL, then the next question is it cheap enough? Do we have enough language budget? And if the answer to this is again yes, then you have to ask, okay, for the given price of this feature, is there no better feature I can implement? And I think going this line, that's like you need to have like 3 yeses, and I'm pretty sure that somewhere along this line of thought or somewhere you make a decision and the answer is no, and you can say, okay, then let's just not do this, spend our budget somewhere else and be happy.
Now, I haven't spent very much personal engineering budget, but you're talking about language thinking budget, language for new people to look at budget. Yeah, and there I'm already burned a lot of budget energy. The syntax I have is extremely simple and extremely short, and is way terser than what people are used to.
In the same way, like JavaScript, it's like it had like really simple concepts, but they didn't turn out to be simple for the code that was written.
If you try to make
is hugely popular, like vastly, enormously popular, and now because it's popular, you can pound on all its flaws. But it touched a thread somewhere, and a billion people, jumped up and down. Okay, not a billion. Millions have jumped up and down and said, "Cool."
Yeah, sure, but it's like worse languages are always more successful, more popular because
no. It's
absolutely.
It's first, the language becomes popular, and then everyone can say there's a better one. No. But but first it became popular because it did something right.
Yeah,
I think it's largely marketing and timing, but
I hear you, but I don't believe that's entirely true in case of JavaScript. I think they did a cool, low-level functional programming language.
They touched the browser.
People resonated with. Followed shortly by, it was attached to the browser, which exploded, and it followed along, and people could look and say, wow, it's pretty reasonable. Yep. Now, it doesn't have any typing, and so the typing number said, none is not a function. You have a billion typing errors, and you had 13 layers to do equals, because equal and equal and equal all mean different things, and, string is not a number, is not, but they're all equal. What a fuck. There's a million stupid
But one equals null, yeah.
Yeah, you can tell all the things that are wrong after the fact, but the fact of the matter was, I believe if Fortran had been pushed into the browser, it would not have been the popular choice to code in the browser. JavaScript was a decent language to go there, and a decent language in general. And then it went hog wild and got crazy, and then...
Yeah, right. Okay, so look at the other property of JavaScript that makes it popular is the same reason, Smalltalk works so well. My development environment was my actual runtime environment, was my execution environment.
Yeah.
Which means my brain just gets the right, basically satisfaction hit because of the turnaround cycles.
I have programmed in these systems before. This is Turbo Pascal. This is any fourth system on the planet. As soon as you have all those run together, it makes it a really convenient language to get shit done in.
Bingo. So it's the compiler is the problem. So get rid of the compiler.
Okay. No, that's part of the intention is to REPL from day one.
Yeah, sure.
Oh, fine.
Well, when I'm saying that the worse languages are more successful, I'm thinking about is like, okay, you have JavaScript, and I think it's imaginable that a person who like spent another year on that language would have created a better language, but JavaScript in the end won because they needed a language like in 10 days and they got a language in 10 days.
Right.
And that's what I'm saying. The worse the language is, the more successful it is because getting things right takes time. And this means that in a place where like timing is of crucial importance, a better language will always lose in terms of being popular.
Yeah.
Yeah, I'm still in the zone of that you're putting the cart before the horse.
No, I don't think so. I think he's nailed it. I understand what he's saying.
Yeah, I heard it. I got it.
I don't know.
But fine. But maybe we're saying the same thing and just looking at it front to back and back to front.
Yeah. One thing is pretty clear. Go ahead.
Yeah, he's saying that it takes time to get things right, and in the operating environment or the state of the world at that point in time. Meant that better was taking too long.
Java was available and was not chosen.
Yes, because you have a compiler.
Because of Java C.
So I don't have this type feedback loop. It's the type feedback loop that did it.
Yeah. Okay. Yeah. And they wanted to. Yeah. I think that's fair.
I can go into my browser, I can type code, and I can see it run right then, there, and now.
No, and that does make a huge difference. No, I'm definitely buying to that.
Lowers the barrier.
Right. Yeah.
Right? I mean, I can just play.
What does this code do? Well, let me go run it and find out. It's a huge improvement to usability. Absolutely.
Yeah.
Same for Python, same for R. And these domains and these languages, they all have a REPL, which is heavily used to this day and makes it part of the lowering the barrier to entry.
And Smalltalk was the same. Very low, very
fine.
With a REPL, right?
Yeah, yeah.
So why didn't they pick Smalltalk?
Because they didn't have a way to pull it into the browser at a timely fashion. As far as I know, at that point, there were very few to none open source, highly available, highly reliable Smalltalk.
So
closed source.
The history of that is that it was closed source and getting licensing to open it up was impossible. Sun tried, failed.
Oh, okay.
Which is why you get, even before Oak, there was another project that was more Smalltalk-like.
Oh, really? I came in when Sun bought Anamorphic, which was a startup that was re-implementing Smalltalk in open source.
They went to Park Place initially to try to get Smalltalk.
Yeah.
Want it.
And Xerox was like,
yeah, Xerox, basically shut that down, and unfortunately, that it killed them.
Yeah, world be in a different place. Fine.
Yeah, Xerox was still pissed off that the mouse got stolen.
Yeah. Let me know how well that's going for them.
Yeah, I guess they're radicals, right? They only hold grudges for like 5 generations, or moderate radicals.
Dude, time to move on. Fine.
So. Okay. Anyways,
all right. So I now I have a language complexity budget. I want to know how far over the top I am, and one of them is, hey, operators. And if I don't tell you I have operators and you don't actually overload them, you'll never know.
Well, if
I have other language budget costs.
If I see a brace and I get anything other than array behavior, I'm not going to be happy.
Okay. So if you see a brace and you see on the left-hand side of the brace something that's blatantly not an array, what are you thinking? This should be a syntax error or something fucking going on here?
I'm going to throw my hands up and say, I don't know what the hell this is.
Okay. So Python does this in spades. Python dictionaries, square brackets all the time. People love it. Not claiming that you should or you should not, but it's all over Python.
Yeah, Python is our poster child, then yeah, we've lost the war.
Well,
already.
okay, JavaScript does it too.
Okay, we've already had that. We've already been down that road.
So I'm just saying 2 very popular languages do this thing.
And popular doesn't mean good?
Popular means it solves a lot of people's problems.
Yes, REPL.
But also the square bracket for arrays was voted in by these camps all independently, and all are highly used by lots of people.
I guess it really is just who do you want to cater to? And I think the unwashed masses would definitely prefer, the square brackety thing. And it's probably more the people on this Zoom chat that would have issue with it. So maybe that makes it wrong to have a problem with it.
I'm leery of saying unwashed masses about my peers who I would like to be able to address sort of directly all the time. So I'm willing to say,
you're saying that those Python users are your peers?
I think familiarity is an important point, but it's like if your feature has only one thing going for it and it's familiarity, then it's questionable.
No,
it's
I'm letting familiarity buy me some more budget to spend elsewhere.
Simon, it's also about readability. And I will tell you that Java's lack of operator support on things like big int and big decimal, it completely fucks the source. I mean, it's an ass fucking.
If you have to use big integer, it's suck to look at. Yeah.
Yeah, it's suck. Thank you. Thank you for cleaning up my language.
Horribly.
It's awful. And it doesn't mean that I expect big integer to get fast if they had operator support. It means that I want the source code to be readable. Like making it unreadable just to prove it's slow is an awful, awful answer.
I'm not arguing against method overloading for operators or operator overloading at all. So it's like add a method fun, add a method fun minus, a method fun mult or something, and then do the syntax sugar rule. If the type has a method called add, you are allowed to use the plus sign and so on. Then you have like...
I have that syntax rule. So I'm expressing that syntax rule a little differently, but I have that syntax rule. If you have a method called underbar plus underbar, you're allowed to use plus in an infixed position and make.
So are you using the underscores anywhere else in your function definitions?
No.
It's like that's complexity.
I could. Haven't said no to underscores for other things like
that's
dummy arguments. You have to have a 3-argument function here, but I'm going to ignore your 3rd argument. So.
Yeah, but that's a different use of underscores. I mean, I just from the declaration side, it's like complexity I wouldn't spend. I'd say here's like a fixed set of method names, and these method names map to a fixed set of operators, and that's it.
That's it.
And if you whether you say that, okay, I bundle like some operators into interfaces, and people have to implement interface to actually also like get operator overloading, it's like I don't care. It's like it could be done. Some languages do it, others don't.
Though. That's a good point.
So what I heard was limit the count of operators, and they map to a known function name, which is what Python does. There is a fixed set of things that can be operators. They map to a fixed set of functions, except that the argument types are different according to how the dispatch is going to go.
The problem with that approach is that list is not necessarily finite. Like imagine you have.
Well, it is in Python. It's finite. It's big, but it's finite.
But making it finite limits what you can do. So imagine you got arrays. One-dimensional, two-dimensional, three-dimensional. How many dimensions are you allowed to have? So if you're only allowed to have 10, when somebody needs an 11-dimensional array, they can't use the operators with it anymore.
Yeah, I don't know if Python has an unlimited count.
How would you use an 11?
I don't know. It's a.
It happens.
In the envelope is what's a reasonable request, but it.
Right. Somebody out there will tell you I have an 11-dimensional array. Each of the dimensions has 2 values, 0 and 1. And I only have, 2 to the 11th possible choices here, but so I want to do an array on it.
My 16-dimensional array of, of bool is called a 16-bit integer.
Yeah, right. In fact, I think Cameron was getting pretty close to that's how he's defining his 16-bit integer.
That's...
I'm not claiming, so I'm just saying, if you choose to go down the path of saying there's a fixed size, there's a key, so I'm going to reiterate Keith here, you cut out certain use cases and you limit the ultimate flexibility, maybe for nothing other than I choose to do this because I'm trying to make it harder to write unreadable code.
One example which always comes to my mind is like some languages have this exponentiation operator.
Yeah, right.
And some languages decided, okay, we add special rules to make it right associative.
Oh, right.
And some languages like decided, okay, that's a bridge too far, we don't. Right. And for me personally, it's like I will never have support like operator overloading support for that, because like this decision of some languages doing it one way and some languages deciding to do it another way basically forces me to come up with a way to educate people. Okay, how is it done in my language? And it's like the bridge is burned. It's like I will never do this. There's like a method for it. It works like a method. It looks like a method, and that's it. Because it's like it's not recoverable.
My argument against DSLs is the same thing. The cognitive requirement for it is too high.
Yeah. If you're writing a DSL, the cognitive load is obviously lowering for you, but for the reader, there's a hump to get over.
There's a great application of the simplest possible version of this language without operator overloads. And that would be to use it to write the closure compiler for AA, which would enable developers to invent DSLs and, context altercations that don't exist in the,
I'm intending AA
language
to eventually self-host. So we'll see where we go.
The precedence or the
precedence and associativity are the two open questions. I have my answer, but I want to hear what Keith has to say here. Yeah.
Have you considered numerical operators like plus and star for vectors or matrices?
Yeah. Okay. Let me hear Keith first.
So you could imagine that the language would let you say, this operator is left associative and this one is right associative. But what happens when somebody defines in one context, the star needs to be left associative. In another context, it needs to be right associative. Now what?
Well, the rule for that one is easy, although I'm not heading down the path you're headed. The rule is I have lexical scoping. If you've replaced an operator in a scope, in that scope, it behaves how it behaves. When you leave that scope, you're back to the prior operator, which behaves a different way.
But I think the problem
the whole point of overloading is both are present at the same scope.
If you write them both in the same scope and you give them unambiguous types and different associativity, then I claim that you're putting yourself up for a world of hurt. In my particular case, I say don't get to set the associativity rules.
That's exactly my point. So if the language lets you go to a place where you're going to feel a world of hurt, that's not a good thing.
Right. I'm claiming I'm not going to allow you to set associativity rules because of that issue. And for the same reason, I won't let you set precedence rules. Okay, I'm ready to say precedence. Oh, for each operator, an operator independent of its overloads, the operator itself has precedence. That's where I'm currently sitting at. You can have more overloads for an operator. They all have the same precedence and associativity.
Yeah.
That's tied to the syntax of the operator and what the parser, that's how the parser has to deal with it. This is remove ambiguity in how the parsing's done. But it's to remove ambiguity in how the programmer reads it. Always plus is, whatever, left associative and dispatches on the left argument.
But then you have that problem. What do you if you freely allow people to pick the operator names? How does it fit into your fixed definition of associativity?
Well,
it's like Scala did this thing that said we look at the first character letter, the first character, and it kind of worked, but it was scary because they also had like special rules for something like the plus assignment and minus assignment.
So so if I come up with a rule for plus assignment and the op assignment with the left hand with really an L value, then I'll make that stick with how all the other operators doing because of what you just said there.
I think I remember. I think they had like the rules. They look at the first letter for the precedence, except if the last letter is an equal sign, but it's not something like equals, and then they have of course like if the operator ends with I think colon, then it's right associative.
Right, I remember that.
And I think it's like the perfect, like it's impressive that it works. It works better than expected, but it's like if I look at these three features and I want none of them, it's like I don't care. It's like
so the answer is that somebody tried this and made it syntactically work and kind of sort of, and oh my God, there has to be a better way.
So the question about whether the language allows a code author to create new operators introduces the question of how do you define the precedence of that, if it needs to be between the precedence of plus and times.
I haven't decided there. The two obvious schools floating in my head are what Scala did, where you grab the first or last character to decide this is the precedence, and the other choice is you name I am landing between these two guys. I guess there's a third choice, which is to say it is at a fixed known precedence level for all weird operators. All weird operators land at this precedence level and fucking use parens if you don't like it.
Yeah. So if you want to have two operators between plus and times, but one is more, needs to bind more tightly than the other. How do you say that?
Oh, you do them in order. I insert one guy and I say I'm between plus and minus, and then I insert the second guy.
What if they both say they're
the authors of those two operators don't know about each other? Now what?
Yeah. I think there's an approach where you can define the precedence with floating point values and can just add digits.
One way you can go around that is that each character you define a precedence. The Scala does this. The precedence 10, precedence 8, precedence 7,
you pick
0.
An integer number.
And you insert your operator at the right level.
You floating point.
Yeah, but I think the core question is like having allowing people to define their own precedence levels has cost. It's like it's like for instance, like it's scientists say like people can keep 7 things inside their head at the same time. If you have 7 levels of precedence, basically people have run out.
This is what I tried to say earlier. You cannot make everyone happy. You shouldn't. If you try to make everyone, the APO people and the Java people happy, then none of them will be happy. And
there's a language that was successful trying to make everyone happy.
No.
C++.
Wow.
Well, like it was successful. I mean, he put every single feature in that people asked him about.
Yeah. I guess the thing is like people don't know whether they are happy or not, because like the only people who know C++ are like 10, 12, 15 people on this planet or something.
So there's Chris asked a legit question. You know, what would this guy do? Well, you didn't tell me how many arguments it takes. And then at the moment, I don't know what to do with Lvalues. So you can't be a plus minus equal per se. It can't be a guy. Here's somebody going $, plus minus.
That will be my next question. What about uniform function call syntax?
Yeah, the operators all can be called as a function as well, as a uniform function. Yes. To do that, you have to use the operator as a function pointer syntax. So you don't get to use the split syntax for square brackets. You have to use bracket equal as the operator. But then it's an operator, and yeah, it's operator. It's a function. It's a function call. It's a function pointer. You can call it. Yes. Yeah, ones that no one complained about, no one's used. Yes, exactly. So we're all happy to complain.
Yeah,
to go back to operators, have you considered restricting commutativity? Say you wanted plus to be only used for numerical values, and you don't want anyone to use it for something crazy like strings. You could actually restrict that by requiring that plus has to be commutative. Have you considered something like that? Allowing compiler to rewrite
because
plus b to b plus 8.
Floating point addition is not commutative.
It's not associative. It is commutative.
Plus 0.
A plus b equal.
Can you plus a 0 minus 0? And if you do different kinds of weird nands and you add them and you swap them around, does it change the resultant nand you get back out?
Nan plus then is nan.
I'm sorry, it is still commutative?
I think it's not associative.
I know it's not associative. I'm asking, is it commutative under all circumstances, including fucking weird nands?
I believe IEEE 754 is.
Okay. Yeah, what is A plus? So whatever A plus B is key. That would be, you have defined what plus is supposed to mean. I'm assuming A and B are actually, they're not allowed in an operator. So A and B are variables, plus. Okay, yeah, what did you define it to be?
So
you're saying how you parse it.
Your earlier comment about,
I got you. Okay, so I parse it.
Significant or they're not. So in the definition of plus, you can't put a space between the 2 plus characters. But in the usage of plus, you can't have a space. But when there's no space between that operator and another one.
Yeah, I have a very simple rule, and then you could argue that it's still not clear enough. And the simple rule is greedy longest.
Yeah, I mean, you have to think about it and
right, you do. No, you're correct. Suppose I have a plus and a plus, and I have a unary plus that's just, does nothing plus, right? The standard unary plus.
That one, but.
And you lay them out like you did. They're A plus B. What the hell does it mean? Well, greedy longest says I have the 3 plus operator. But if I don't have the 3 plus operator, I only have the 2 pluses and the 1 plus, what's it mean? Well, you get the 2 plus operator is greedy longest, followed by a split, and then the separate plus is the unary leading plus.
Yeah, I mean,
that syntactically is annoying to read, difficult to read.
Problem, and I think you're right. You stick a space between the 2 operators where you mean it to be.
Yeah.
And everything works. Right?
But is there anything that the plus postfix can do, but like I plus 1 I equals I plus 1 doesn't?
Yes. No, the whole set is not. It's the assignment is always special.
Yeah,
so it's an Lvalue. So in the assignment land, you did a computation on the right of arbitrary complexity, and you did an assignment. Plus equals does an assignment as well as the assignment as the normal assignment. And the assignment is not an operator. I don't have an assignment operator.
Yeah, I think that's like on the one side, I'd say it's like you don't need it. And on the other side, I'd say it's like I wouldn't even want it, because like if I'm assigning something, I want to see an equal sign, at least one. Yeah, and having like this special magic, there's plus plus, and then it does.
I have used plus plus and the plus equals many times, and only extraordinarily rarely do I do times equals and minus equals and divide equals and all the other ones. Plus equals shows up fairly commonly.
Yeah, but it's like, it's certainly less convenient, but like I think it's like one can do without it, like exactly like without plus plus. So it's like language complexity, like regardless of what else you decide, I wouldn't spend language complexity on plus plus.
Well, I've implemented plus plus already, but it's not an operator.
Yeah, rip it out.
Because I had to do it as an assignment with the Lvalue piece, and so I leveraged my Lvalue logic.
But you said you don't have assignments. I mean, if you
not as an operator,
right? But if you can do plus equals, doesn't that mean you would inherently have an assignment operator?
No, it means I have to have an assignment in implementation of plus equals so that it doesn't end up falling into the operator precedence camp, overloading operator camp. It is a special syntactic form. Right now, plus plus for me is a special syntactic form. It goes to a private branch in the parser called the increment, minus minus plus plus, which does I'm looking for an identifier on the left just the same way as I look for an assignment. And then I see the plus plus, and so I now look up whatever. But he does with normal things after that. But he does a special thing that says, find me an Lvalue.
Right. But when you give the option to define an operator, to overload an operator plus equals, that would be different, right?
So were I to give you a plus equals operator, I would have to figure out, I'd have to figure out how to deal with Lvalues in the operator precedence tables. And the parser would have to deal with Lvalues. In particular, I have function, every operator turns into a function I can just call, but you can't call an Lvalue. So I have this issue that I can't call as a normal function, like I can with all the other operators, plus equals, because I can't give it the Lvalue. I can do it with arrays, where I have the array base and the index and the value, and that plus equals I can totally do as a function call. But the standard x plus plus or x plus equals 1, go find the x, it's not an expression, it's an Lvalue, and that's different. So like if I want to say plus plus as an operator, and I have parens and I have the normal call syntax, and I put an x as an argument, that's not an x as an argument as an expression. That's an Lvalue, and that's what's weird. And that's why you can't do it as a standard function. And that's why I'm at a special syntactic form for that.
Leave it out.
I'm sorry?
Leave it out.
Yeah, right. And you're proposing leave it out, and I'm like, twitch, I don't want to, and twitch, it hurts. So yeah, right.
Actually,
open question. You might yet get left out.
Lvalues aren't really much more special than regular function calls. So you got some type, and you define a function that takes no arguments, and it applies to that object or that type, which could do the auto increment or whatever it needs to do, and then return something like.
No, the increment had a side effect. As soon as you said Lvalue, you have side effects. So you have to pass a side effectable thing into the function.
Yeah. So it's called this in some.
So if I have just a free local variable floating around, I'm passing in. You're proposing. I hear you. And in fact, I went there while you were talking. I went to the same exact place. This can be done this way. Not sure I like it, but yeah, you'd pass in this pointer, if you will, and the field offset or field index, however you want to call the field, which is fine. And then you side effect to this pointer. And maybe that's the right way to go do Lvalues in this kind of a context.
No, I mean, atomic integer in Java has an increment and get or
well, atomics
get an increment, or whichever or both, right?
Yeah, I would leave atomics, maybe not. Maybe they totally apply here. Atomics have a funny thing that they need an Lvalue.
Ignore the atomic component of that name, but
okay. Yeah, atomics have a funny special thing in that they're their own
immutable,
game.
But atomic integer, or imagine the non-atomic mutable integer has a same.
You've passed in a this pointer to hold your state, which I could totally demand for an Lvalue type.
You take that idea and apply it to primitive types as well. Everything just works, isn't it?
No, the primitives don't have a state, so they're just a value. So to do it with a primitive value, you actually have to have something that's a this pointer equivalent and a field. Your display frame, your functions frame, your something has a state.
You need a reference to the place where that primitive value is stored.
Right.
Exactly. Now you said it's stored, but hey, it's just a free variable in my function. It ain't stored anywhere.
Well,
there's a difference between next and increment.
Yeah, exactly. The difference between next and increment. The next is the +1. Increment side affected you.
I think C# uses the approach of having some special name for this purpose. I think in property syntax they have like this special name value where you can assign things to it, and maybe that's an approach.
Well, I would claim I'd have a special syntax. If I wanted to have an Lvalue type operator, I would need a special syntax. Or I would claim immediately it's a 3-argument operator like an array setup. And the 3-argument operator takes whatever the frame, the closure, it takes a field name, a field index, a field something, and whatever value, 1 for ++, and
I mean, they have like a special name called value, and they basically use this to understand. Okay, you are trying to assign whatever you do in this method or in this operation to this Lvalue in some kind. That's basically how they expose it syntactically, and what they do underneath is something different.
I think it was just a different way of saying this.
Like the const and non-const distinction in C++, right? You can't apply the postfix ++ to a const value, but you could to a non-const value.
I think well, my issue is something different, or I'm still not sorted. I think I've settled on what I heard you say originally, which is if I do them at all, it'll be there's effectively a this pointer and a field. It'll be like a dictionary operator overloading version of things. It'll have a collection, which is your local frame, your stack frame, a field offset, and whatever the value you're incrementing. And that would be a way forward. It's definitely nastier than however.
Well, at some level, you just got to make some decisions as to which things are important in the context of your language. And
right. I originally went down this path because I liked how they look and read and how I used them. And then I'm busy replumbing the primitives. And so I've retouched a bunch of things there. And so I'm trying to reset the implementation that all primitives are just a standard function call and use the uniform function call syntax and yada, yada. Now suddenly we use Lvalues. The other one is shortcut operators, which I'll probably also implement as a standard uniform function call syntax, but it takes essentially a thunk on the right-hand side.
So I like your characterization of this pointer and a field offset, whatever. If you think of the stack frame as kind of an arbitrary structure, generated by the compiler, then you always have this pointer and a field reference, right? So it's just a field in the local stack frame.
Yeah,
whatever that means.
That's actually how I'm implementing AA right now. The typing system and all that. The stack frames are explicitly manifested in the typing. They're not brought out to the user mode, the user land, so you don't see them, but that happens in the typing. So I could type a += operator as a uniform function call syntax. I could totally type that. I just haven't thought about actually implementing the overloading such that it implements that way.
You just need type safe pointers and then you're done.
Right. Well, I'm trying very hard not to. Currently, I don't have any type safe pointer. I do. The typing system under the hood has them, but then no user land type safe pointers. And maybe the answer is I should give it up and go there. Except I didn't want to have interior pointers as an issue for all the GC things in the universe.
Well, if I think it's Rust where you have the the notion of borrowing. So if your L value is only used in a context where it's borrowed for a short time period and doesn't escape, then you never have pointers to worry about with respect to the guard.
Right. Under that model that says operators overloading is always inline, and then they fold to the flattest possible thing. And unfortunately, if you give a user a chance to an operator overloading, he'll go hog crazy, hog wild, and you won't want to inline it. But maybe you inline it down to the point where the actual assignment happens, and so the L value is well limited in scope and disappears from the user's point of view. Like when the user gets a function call, gets a uniform function call that he's implementing for an L value type thing, under the hood somewhere, he has a this and an offset, and he has to do an array-like syntax to do an assignment, or he failed to do an assignment as, or whatever, but he's getting an L value-like thing. How does he in turn assign into that L value-like thing? I don't have the L value assignment syntax per se. Not exposed. I only have the unexposed.
The borrowing notion, I don't see how it has any problems if you don't inline things.
No, I'm saying the implementation. It's not about borrowing ownership. This is about implementing the next layer down. I'm implementing, a user wants to write a plus equals. Yep. Okay, so they get an L value. What's an L value? I don't have a user defining L value, and they're trying to write a function to use an L value. They don't get it. I mean, I don't have one exposed. So I tell them they get this pointer and a field, except that they now have an exposed direct reference to a stack frame field that they can then choose to update. And now it's getting a little twitchy on me, like what the hell? Right? Yes, exactly. I'm not certain that I want to go there. Like what's the implementation? We can go back to the damn document here. Here, I'm going to go to the bottom somewhere and write a new banana. Okay, here's people doing things with arrays. That's read CSV. I'm going to grab, let's see, I'll just start a new thing here. So someone wants to implement a plus equals operator. And so they define plus equals as an operator, which takes an L value and an increment value, and they write a function that does something. Okay, the problem I have here is I don't have a thing typed as an L value that's visible to the user. Now I can give them two different things. I can give them a this pointer, and this is just a normal variable name here, and a field offset. And again, I don't have a user-defined type for the this pointer, but I could, and it could claim it behaves like a structure assignment or a field assignment, and it follows the same rules that you can get to the primitive version. Offset,
And you implemented the array access with operator overloading?
I'm trying to write so the what somebody else wrote as an alternative syntax is the ampersand to say this is a reference field, which internally under the hood consists of a this and a field offset, which in my example syntax, I wrote out as a operator overloaded version of an array assignment. It's a collection assignment. It's in a collection assignment, right? So in whoever's writing the ampersand var equals inc ... fill in the ... You have to have some more new syntax for the var.
Okay, so
you've got a new weird type for var. It supports being on the left-hand side of an assignment operator. Okay, that's a fine syntax. So var is a special L value typed.
Just a name.
No.
The ampersand in front of it that makes it special.
Yes, the ampersand turned var into a specially typed thing, which under the hood actually had some parts to it. It had a structure base and an offset. That was
because that's essentially what Rust does. That's how you borrow the.
Yeah. Okay. And as such, it supports being on the left-hand side of an assignment. And which is fine.
You can pass it to other operators that use it in the same way. And
right, so right. And then you have to have, well, you've made ampersand var a first class type in the language.
So yes. Is this ampersand used anywhere else?
not for me.
Or is this just,
well,
it's just invented for this special use case?
Just right now, it's invented for the special use case because it plays off of C's address of operator, right? C's
okay.
Address.
So the follow-up question, can you overload it?
Yeah, exactly. No, you cannot.
Well, actually, I think C++ lets you override the unary ampersand operator.
Yeah, and to mean address of it probably does actually.
To mean what you want it to mean.
Right, but if you want it to mean be a unary address operator, and also print the word "here I am," right? Print "help me."
It should behave in the way users expect, and they're going to expect it to be something like an address. But yeah,
I don't know what the hell the users expect here. And ampersand shows up in other namespaces as a primitive for doing bitwise math and shit like that, but that's a different namespace. It won't be in the parsing of a function call syntax. So I would need a type syntax for it as well. Like the ampersand equal in my head, it turns into a, whatever, who's typing now, that is normally would be a anding operator because I'm doing a bit mask. I do that kind of shit all the time. I'm doing bit masks. I'm busy writing a big integer sparse bitmap set thing. I have ampersand equals all the time. Right, as soon as you put that on the variable on the function call header, it is C sharps. I don't know how to read that. Value. What is the word value there? Is that a special keyword?
Yeah, it's contextual keyword.
Okay. Yeah, I don't have keywords in those kind of things. You'd have to have a special keyword. I like the if I had to pick a keyword or key indicator, I would use the ampersand, but then I have to have Lvalues as a user visible type. You can pass them about, just exactly what Keith said, and then you can use them in nested and whatever. You means you're passing around an Lvalue. Okay, you are. You're passing around an Lvalue.
We ended up with the exact opposite choice, which is we have Lvalues at runtime, but we don't ever use them for operators.
Oh, you don't
so
ever
Lvalues at compile time are treated completely differently. So we can say ampersand on any, on a variable or property or whatever, and we get a type safe pointer to it, if you will.
Right.
Something that you can store a value into.
Right. It can land on the left-hand side of an assignment operator.
Yes. Well,
you have to be careful.
It's an object who has a method called set that takes a value of the referent.
Right, right. And then somewhere under the hood set becomes a primitive which does the assignment.
You don't want to let people take Lvalues or take the address of an R value, because somebody says set ampersand 42 comma 0, right? Like, I don't think that's right.
That would be a type error, yes. And now the syntactic restriction that flows from that is that when you have an Lvalue typed parameter and you want to use this somewhere, there has to be an Lvalue available to be used. And if you do the normal uniform function call syntax, you cannot put an Lvalue in an argument position. So now you have to allow the Lvalues to appear in argument positions by using ampersands. And then the thing on the right of the ampersand is what you could find on the left of an assignment. And that would be, technically sort of correct and be passed around a lot, but it would be certainly, maybe it's the right answer.
To Keith's point, though, I think, I look at the fundamental issue differently, which is the number 42 is easily provided as a reference to an int. It just happens to be a reference to an int that cannot be set, right?
Or you put 42 in a brand new location, pass it off to somebody, and they can modify it all they want, but 42 is still 42.
That's correct. That is correct. Yeah, I mean, that's why we call it an R value.
Well, I would claim that you can't take the ampersand of 42. That would be a type error.
It has to be a new copy of 42 that's mutable.
You can't get an Lvalue with an ampersand on 42. I agree with that.
Yeah, that's what I'm saying. You can't get an Lvalue. Yeah.
Well, that's a language choice. I'm not advocating for it, but you could do it.
No, I'm also not.
Well, what I heard you say is we just make another copy of 42, which I claim is a different. You get it because it's a normal value. 40 is a normal value. You get copies all the time anyhow. That's what you normally do.
Yeah, but you have to have a private copy that you can pass the address to whoever.
Okay, no, that's a different, that's the game I'm saying no on. So as soon as I have a private copy of the address to, where did the address come from? I did a memory allocation to put it 42 in an address slot.
Yeah.
Okay, so that tells me that the ampersand is an allocating operator. And I'm like, no, allocation has to be under another syntax.
I won't go that far with you. The ampersand just says there is a place that you can refer to this thing. That doesn't mean that it wasn't already there.
If I run this in a hot loop,
I'll figure out, where it needs to make.
Right. Okay. So I'm running this in a hot loop. I promise you, I need 1 billion unique 42s that I'm going to screw with. I need 1 trillion unique 42s. Where are you going to allocate them?
Well, in the code, I'm only making reference to it once.
No, in a loop. And every time I take the reference and I pass it off to a function which does you don't know what to, turns out it takes a random thing and does something horrific with it. And therefore you have to actually implement the code. It hands me unique new 42 every time. Where are you doing the allocation?
Well, in the same place you're putting the,
you can't have one is what I'm saying. You have to have 1 billion unique ones.
No, I mean, you already had 1 billion unique activation records for those.
Yes. Okay, so you're claiming the lifetime is, I can't take this Lvalue and store it off into a big old array of Lvalues, pull it out later and see my modifications to it. The lifetime of the Lvalue is my stack or not.
So if you copied 42 to a location in your stack frame and then pass the address of that off to somebody, then you can see the changes.
No, I didn't. I said address 42, 4 equals 1 to trillion. Address of 42 is passed off to some arbitrary unknown function. You don't know what it does. Turns out it's going to save that address, that Lvalue, and diddle with it later.
Yeah, but you can't look at it because you didn't capture.
No, but the function I call can totally look at it, can tell that he's got 1 billion unique 42s, and he's modified them accordingly.
No, he's only given one of them.
He's got state. He's hanging on to that 42 and the next 42 and the next 42 and the one after that.
No, first of all, that's why I argued that it wasn't an R value. If you took the reference to 42.
Right. It's not an R value.
It's not an L value. It's an R value.
If he's allocating, I heard him say we do allocation.
No, I didn't say that. You heard something that made you think that, but that's
not. No, if I play the video back, you said, we allocate space, but that's fine.
Well, okay.
Isn't asking for a reference to something
I'm not trying to fight you here. Really, I'm not.
Yes, those words came out of my mouth, but that wasn't the interpretation you were supposed to take away from.
Excellent. So I don't understand the interpretation I'm supposed to take away yet.
Okay.
But so if we did run into that exact issue where once you take a reference to something, even if it's immutable, if it's inside a loop and inside the loop, you allow it to escape by, for example, calling something with that reference, then yes, the closing edge of the loop has to lift the value.
Yeah.
Right? Because you're collapsing the scope as you hit the closing curly brace, so to speak. And the next time through the scope, that value can't be in the same place because you've handed off that place. So basically,
the reference is not allowed to be live the next iteration through the loop because you've destroyed it.
No, okay.
If somebody has a reference to something that's been destroyed.
It's a decision. It's a decision. So when we take a reference, if we don't hit the closing, if it doesn't survive to the closing edge, then it's a free. It's just a mathematical operation to reclaim the memory.
Yeah,
but if you do hold it somewhere, then it escapes that scope and it actually has to be dynamically allocated. So it's kind of pay it if you use it.
Okay, so I was coming up with a scenario where it escaped every time. I hear Keith now saying I'm using a Rust borrow thing to say the scope ends and therefore it does go away and can't be recycled.
I'm thinking, the Rust model where, you can't store the borrowed reference that in a place that outlives the lifetime of the reference.
Okay. That's a different, that I did not hear until just now. So
is there a reason it can't just be the compiler's choice? I ask for a reference to a mutable thing. If my reference escapes, I can lift it at that point, or I can
Aaron, there is, and that is I can write the program where it doesn't where if you don't limit it via some sort of borrow checker, it does outlive the loop. Therefore, the worst case scenario is you have to support the ampersand allocating new storage at each iteration of the loop. Now there's an optimization that says under a lot of circumstances, I can reclaim that every iteration. That's an optimization. That's not semantic.
Yeah, well, I would argue that a language that doesn't allow that escaping is better.
Okay, no, well, you could argue that reasonably that if you use an ampersand, the rule is the borrow checker says it doesn't escape your scope. And I'm okay with that. That's a fine thing to do. Having it otherwise allocate every time says something about the cost model that I was going to be happy to argue with. But now, this cost model I can live with.
So Keith, I like your logic, but the problem is what happens when someone hands you a Lambda and it's a consumer and you're in a loop and you're handing it, something, and you just don't know what it does with it. That's the challenge, right? It doesn't know you, you don't know it. Some third party hooked the two of you up, right? So you have three different parties. One produces the producer, one produces the consumer, and one calls them one with the other, right?
Yeah.
So it's
building a pipeline.
I like your logic, but sometimes the high-level languages deal with people who are not so constrained.
Dumb decisions can be made at runtime.
No, this is a semantic where you have to handle the worst case scenario, and I at least want to give a decent cost model. So if you are calling an unknown arbitrary function with an Lvalue, unless there's some other proof like a Rust style borrow checker going on, you have to assume the Lvalue escapes your lifetime. You are type incorrect if you don't make that assumption. All kind of hell havoc comes after that. So now you've escaped this thing. Well, if you just allocated it and you just escaped it, you have an infinite consumer. And for me, that turns into an excitingly expensive cost model operation. And I want you to be very explicit. I really intended to burn 1 billion, allocations a second, because that will be the 99% cost in my execution. There'll be some huge amount of my fraction of my cost to be spent allocating storage, which I can't reclaim immediately. So
again, I wasn't intending for the escape to be possible.
Okay.
So you don't have, there is no real cost to, passing now, location where 42 was stored, at the time I called you. But
so as soon as I say it's not possible for it to escape a scope, which is fine, I need a borrow checker, which I don't have thrown into my type theory at all. So I'm not able to support that right now.
And what I meant before, Cliff, about, you can use the ampersand for either an L value or an R value. I mean, if I do a DW42 and assemble, I can take the address of that.
Yeah.
It doesn't mean I have to allow it to be changed. I have the address, of course, I'm an assembly.
Yeah, that part I got. As soon as it's immutable, but in memory, then, promote it to a value or whatever. It's a fine thing. Yeah. This was really I'm side effecting the crap out of it, and also I keep making more of them. What do I do?
Right. Well, that's the challenge when it's both mutable and escapable. Is that a good word for that, Keith?
Yeah,
escapable.
Yeah. All right, we are 2 hours. Boy, we had a full crowd and went round and round and round and round on this. It's pretty good. Anyone have any last minute things they want to add?
Last question. If you have things like plus equals and minus equals and times equals, you can add multiple of them into a single expression on one line.
Yeah,
how do you do the precedence?
Right. As soon as you have an assignment there, I'll probably force something weird on the precedence. It'll be because you have an assignment. It'll be assignment ordered,
a complete virtual precedence, which is like the original precedence, but like shifted by -20 or something.
Yeah, right. Yeah, I don't know. There won't be right, and that is a very good point of what is the readability of such a mess. The other option is to say, syntax error, break this fucking line up.
we got rid of the assignment expression for that. I mean, because it's such a it's cute because I've used it 3 times in C, but
me too.
For simple sets of expressions, I allow it, but I don't do any of the operators along the way. So if you say X equals Y equals Z equals 0, I'll just take that fine. But I don't have a X plus equals Y plus equals Z plus equals 1 that I'm expecting to do something sensible with. So yeah, I don't know. I think that one's one where I'm willing to say no on. Like I like the plus equals. I don't like stacked plus equals on a line. And what does this mean?
Well, it's perfectly, or it can have a perfectly sensible meaning. It's just
no, but I want to be able to have it be understandable by somebody who's glancing at it, or would like to be. Maybe you're right. Maybe the answer is it means whatever the fuck the parser chose to mean, and no one really cares. So we'll write down the actual rules, but if you use those rules, you are fucked.
Yeah, you don't need to assign meaning to things that don't exist. Always remember.
Well, right. No, I have to assign a meaning so the language is like complete. It doesn't die if you hand me your random cat barf. Like I have a guy running a fuzzer on AA right now, right? So I get cat barf code.
No, I mean if Cameron said, if like the assignment operators don't exist, you don't have to.
Well, there's that one too.
Well, assignment expression. So the A equals B is a statement, not an expression.
For me, those are all expressions, but I'm not looking at the nested set of them. And I don't have any operators mixed with the assignment, so the expression, so I don't run into this problem you're talking about. If I say X equals 3, that's a 3 and an assignment to X, that's an expression which can be nested inside of a larger expression syntax, but you don't have this.
That's what we got rid of quite purposefully.
Yeah, I have several use cases for it that I personally end up using a fair amount that I'm interested in keeping around. I think that's a style of thing that I do.
Yeah, no, it fits in your language.
Fits in the language, yeah. It would be a nested series of tests where after the initial like null check and instance of, I want to have a shortcut name assigned in the middle of an expression and then these participate in the next set of tests because I'm writing some big S filter. I just want to say if blah, 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 but in the middle, I want to stop and say, now I can up task a bunch of temps to something that I know what they are and then use them as a better known thing in the next series of tests. But it's all one big guard. I don't want to break it up as an if and an open curly and assign a variable to the thing I can now assign to and another if and another open curly, another if. No, it's just one big guard. I just would like to write it all in a row as a one big guard. That's why I go that way.
So this all reminds me, a long time ago at Cognos, we were building a language we called Thunder, and it supported arbitrary operator definition and overloading and everything. I remember that the compiler got really slow if you did too much overloading because it had like too many things to try and decide amongst.
Right.
That
I don't have any. Yeah. I currently have no exponential search algorithms in the parser. It's all linear, constant time lookups, guaranteed.
Yeah. The thing that I still remember I wasn't really happy with was that the meaning of a program can change depending on what goes before the part you looked at.
Yeah.
So if you did define an operator, it means this thing. If you didn't, then the thing broke apart a different way and it meant something else. And I didn't like that.
That gets to my greedy maximal grab question. If you defined that plus plus operator or the plus plus plus, you would get.
So if you didn't define plus plus plus, then my question earlier had to break down to one of those three choices, and you could say the greedy one. That's fine.
Yeah.
And then it has a meaning. Yeah. But if you included some file that did define plus plus plus, and now it's different, that's a surprise that you don't.
You're still lexically scoped. So this only bites you if you forcefully include, like in the Java include, not like the C++ pound include. Java included a definition of plus 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 that escaped its scope to the global scope, which I don't currently have any. You have to ask for it specially. Like you have to make a module that exports a plus plus plus, or you didn't get somebody else's plus plus plus. But if you ate that module and said, please import me all of your namespace, including your operator overloads, you ate his operator overloads. Yes.
Operators in our language were at the global scope.
Right. Mine are not. Mine are lexically scoped.
I forget how we tied them to, methods of types, but.
Right. No, I've seen a lot of languages where the operators were a global scope, and as soon as you throw an operator in, you suck on it.
The operator definition was a lexical concept.
Yeah, mine are lexically scoped, and it's a lexical concept both.
Yeah. So, but an operator could be introduced, but it never goes away until the end of the program.
Right. I hear you. Yeah. And I specifically looked at that model, have used that model, and I said, no, my operators will go away at the end of the scope. And the parser will revert back to the prior parsing.
Yeah.
All right. I'm going to declare victory for the Alliance. It was, as always, it was pretty fun and pretty intense. And I definitely learned something new.
You're going to have to report back on your decisions on this.
Well, ask again, because some of these float around and I go back and forth and screw around. And some of them, you know, I heard a lot of, I like to know when I've bottomed out. And I totally sympathize with that opinion. So I'm sorting on it. I still think I'm going to have operators in here. And if you don't ask for it, you know, it's pay as you go. If you don't ask for it, you don't get them. You can't get them unless you said, please, sir, give me your operators. You won't get an operator. So you can't be forced to eat an operator unless you ask for it specifically by doing a module import and said, hey, give me all your exposed names, including all your operators. Otherwise, I think I'm okay with the DSL that it enables in exchange for the language complexity. Like it's not a huge amount of complexity if you don't use them. It's like,
I'm still not sure I understand your lexical description of these things, or the scoped adjective that you use here, because, you know, imagine I define a type, you know, let's call it a matrix, right? And it's got plus and times and so on. Yeah. And then outside that type, you know, a user of that type wants to be able to use plus and times as defined by that matrix. Well, they're not in the scope of the user, they're defined in the scope of the matrix type.
Right.
So
they
can't disappear just because we're finished defining matrix. Now we're on to the users of matrix, and they need to see those operators.
Right. So there's a different thing here. There's matrix has a funny function name set up with it, and then there is the parser acknowledges you have an operator and will eat it in the infix notation position and turn it into the correct function call. And right now, the thinking I have is that you don't get the operator behaving like an operator unless you export the operator out of whatever into your scope. So just because you're past a matrix type thing, you don't get the matrix operators unless you said, please also give me matrix operators. And now you could argue that that's a bad decision, but the goal of that decision is to prevent me from having to deal with operators so the parser doesn't know it's coming along.
Yeah, I'm thinking most users of the matrix type were going to want those operators.
I agree. And the easy fix is they say, Mr. Matrix module, please import me all your normal matrix support.
Well, I think it should be the other way around. So for types like matrix, I want to say everybody that uses me is going to want these operators. Export them to every user.
Okay, and I'm in the zone of, where did you get a matrix from? You had to ask for a matrix module somewhere to get a matrix type. Well, and at that point, you get to make the call, and now I'll put them in your scope.
Your approach, as long as it's dead simple. I say like import matrix and all operators.
Yeah. You say import matrix, that's it. You got the operators too. Now you could say import matrix and exclude just down to the following things if I wanted to cut out the operators, but you just say import matrix. The matrix module has a list of things it's exporting. You got all those. Operators are in there.
All right. Well, that's not the way I heard what you said earlier.
Okay. Yeah, that's fair enough. And to be honest, this isn't working right now, and I haven't tested, and I don't know. So this is my current theory of how it'll be in the end, you know. So it's a work in progress.
Yeah. Very cool.
Okay. Happy to talk more about this next week.
Hey, Keith, I saw your pull request. Thanks.
Oh, I got my eyes all over the place, Cameron. Don't you worry.
All right. Till we meet again.
Okay. Bye.
Bye.
Bye.